was standing in queue for more than 1 week to buy a pair of nylon stockings, which is made up of coal, coke and heat. Natural sources from which the monomers were prepared and then nylon was made. See the advertisement. See the size of the stocking that was shown. We talk about giant displays now. It was there in 1940. So awards will come, rewards will come. Nylon went into war. World War, all the truck tires of the military vehicles used nylon. The parachutes used nylon ropes. But unfortunately, the person who invented Wallace Carothers at a very young age, for unknown reasons, committed suicide. He did not survive to see the success of his invention. It had become, when the World War ended, polymer era had already begun. Till then it was natural polymers, modified natural polymers, but his invention laid the foundation stone for synthetic polymers. If I am allowed today to use a magic wand and turn it and make all the synthetic polymers disappear from this room, most of us may lose our dress. Most of us, your seats will definitely will not be there. Maybe at the most gold chain and a belt. Nothing else. That's what many young generation is there. If the older people are there, some may lose their heart valves, some may lose the knee joint. All these. So synthetic polymers have entered every walk of life. A newer polymers. This was the glory year in 1930s. Once nylon became very famous, successive, so many inventions came. Newer polymers into the market. Teflon is one of them. I'll skip this. Tires. See the junk tires there. Used tires have been dumped. It tells us how much synthetic polymers have helped us. All vehicles, if the demand for natural rubber had increased, the natural rubber would have been short supply, and that is exactly what happened during the World War. Find out a substitute for rubber immediately, and within 6 months the laboratories came up with synthetic substitutes in all forms: polybutadiene, chloroprene, butyl rubber. Another interesting invention in the same lab, DuPont. The scientists were working, the Plunkett, they were working with tetrafluoroethylene. They were working on refrigeration. And they wanted to carry out an experiment. They had filled a few cylinders with the tetrafluoroethylene gas and tightened it. And in the morning, all scientists came along with the research assistants, the cylinders there, and tried to open the cylinder in order to carry out the reaction, and there was no gas inside. Nothing came out. They were surprised. We had filled it yesterday. It's not a gas agency locally where the agent will take away the gas, the cooking gas. You may get an empty cylinder delivered, but it was a company where they had fixed, this is the amount of gas, everything checked, but then the gas was missing. But the assistant there said, he is the one, you see, the scientists could not, they were still thinking what must have happened. He said that, sir, the weight of the cylinder is the same, the filled cylinder, 14.6 kg, as you see in the, where is the gas gone? But then they realized, that means the matter that they filled is inside, but it is not in the gaseous form, it is not coming out, that means something might have happened. But compressed gas cylinders are dangerous, you should not play with it. So they were very, very scared what to do with it. They somehow got the courage to break it open, they cut it open, the cylinder and found that there is some white powder in it. And what had happened? Tetrafluoroethylene had become polytetrafluoroethylene. Immediately that white powder was sent to the adjacent lab where some polymer work was going on. They tested it and they found that a material is formed which is a polymer. Lot of research was done. Immediately it came out into the commercial field. You can make an omelette. Those who want have omelette, they can have it if you are hungry. Non-stick kitchenware has a Teflon coating. It's a commercial name, Teflon. See, all the hydrogens in ethylene are replaced by fluorine, and fluorine gives a cover to the carbon chain. Carbon is covered. Carbon compounds are not that way resistant, inflammable, not tough. But fluorine, with the property that you have in the periodic table, fluorine occupies a very good position. That gave the property to the polymer chain that is developed as polytetrafluoroethylene, the toughness, self-lubricating properties, high temperature resistance. You can machine it like a metal. So it replaced many of the articles that are made up of metals. Teflon became a very common tool. Self-lubricating, no necessity of using grease in the articles made out of it. Nylon was a polyamide chemically. Once it was understood, polyamides. How that name nylon came? Anybody knows? New York and London. You can draw a fiber with a kg of material which can extend from New York to London. Such a thin fiber can be drawn. But here is a material very similar in the generic terms, polyamide, known as Kevlar. If I make a shirt out of that material, slightly thicker than this, it can stop a bullet. You have seen Jayalalitha wearing steel jacket, or Rajiv Gandhi in his prime days. It used to be very thick and they used to look very happy. But nowadays you will not see any of these politicians wearing those big jackets. There will be a bulletproof jacket made up of Kevlar which can stop a bullet. You may get hurt, but you will not die. Now coming to just chemistry, because this is where your chemistry lesson in the classroom starts. What has been told is the history. Without history, if something is taught, you are not able to link and appreciate. You had a topic on polymer chemistry in your 12th or 11th? 12th standard. You have both 11th and 12th. Chemistry is very simple. In polymer chemistry, you come across only two reactions. In organic chemistry, how many reactions you have come across? Named reactions, unnamed reactions, so many of them. Difficult to remember the conditions, temperature and pressure and the catalyst and so many things. In polymer chemistry, you have to remember only two reactions. One, condensation reaction, and another, addition reaction. You can produce nylon, you can produce polystyrene, you can produce everything. You can produce newer polymers. AB, you can mix them, you can make ABC. Only thing is that how to react them, how to bring about the reaction, and how to come up with newer monomers every time. So nylon 6 is an example of condensation polymer. What is the monomer of nylon 6? Caprolactam. Nylon 6,6? 6,6. These numbers stand for the number of carbon atoms in the monomers that you have used. How do you call a polymer condensation polymer? What is a condensation reaction? A small molecule is removed, most often water. Homopolymer, copolymer. What's a homopolymer? One type of monomer. Ethylene, polyethylene, styrene, polystyrene, like that. Copolymer, two monomers together. Styrene, butadiene, if you make. Thermoplast, thermoset. Say rag picker picks up only certain types of polymers. He doesn't pick everything. Tires remain scattered on the roadside. He never picks it up. Why? Because it's a thermoset, he knows. It cannot be recycled. He cannot take it back to the polymer stage, melt it and then create a new tire out of it. Now technologies have been developed, but for him it is useless. That's why only during winters it is burnt on the roadside, polluting the environment. But there are plastics which can be recycled, taken back, put it in heat it, make it move. So thermosets and thermoplasts are the types of polymers that you come across. One can be recycled because remolded, whereas thermoset is not. Linear branch cross-linked, you can have a long chain, you can have branches, the properties change. You can have cross-links to make it a thermoset. Crystalline and amorphous. You come across solids, amorphous and crystalline forms. The definition of crystallinity in polymers is different. Polymers themselves are not small molecules which can be made to sit at a, unlike smaller molecules which can be stacked properly to give a crystalline ordered structure. Solid requires an ordered structure. So crystallinity is slightly modified when you apply it to polymers. At the most, you can push up the crystallinity, but you cannot get a 100% polymer.